Hey everyone, welcome to 2.4, the chain rule. One of the most powerful rules is the chain rule. Kind of like Mr. Bartman is probably one of the most powerful math teachers. And it deals really with composite functions. What's really nice about the chain rule is that all the other rules that you learned so far that you really need to take with you is that they work for like a function, but not for a composite function. So the chain rule says it doesn't matter what function you have, you can use all those other ones plus this one to make really complex functions differentiable. Alright, so what was possible before the chain rule is that we could differentiate x squared plus 1, or sine x, or 3x plus 2. Now with the chain rule we can differentiate things such as y equals the square root of x plus 1, or x squared plus 1, y equals sine of 6x, and y equals 3x plus 2 to the 5th power. Alright, so here is the chain rule in words. The chain rule, if y changes dy over du times as fast as u, and u changes du over dx times as fast as x, then y changes dy over du times du over dx times as fast as x. And you say, huh? What? Mr. Bartman, I don't get it. That doesn't make any sense. Okay, well that's alright. First let's just look at this thing real quick. What is dy over du? Well, you know that is a rate of change, an instantaneous rate of change, right, at u. And we can say this one is also differentiable. It is one of those things, and it is the rate of change. Again, rate of change. So it's kind of like saying, can you find the derivative at u? Can you find the derivative at x? And then multiply those together, and you should be able to find out what the derivative is for y, which is that instantaneous rate of change at that one specific spot. Okay, so we're going to do this, and I said, example in context, a set, and never mind, we're not going to do that whole thing because I didn't want to write it out. So what I'm going to do is I'll pull it up here right in just. Alright, so here it is actually, everyone. It says that a set of gears is constructed, as shown in the figure, such that probably don't need to be doing two things at once here. We're reading down here. A set of gears that's constructed as shown in the figure. And you say, well, what figure? I don't see this figure, Mr. Bartman. Actually, you do see the figure. It's right here. Okay, so it says, let's even move this over here so we can see it. So, a set of gears is constructed. As you can see, it's kind of a three-dimensional picture. As shown in the figure, such that the second and third gears are on the same axle. So you see that gear 3 and gear 2 are on the same axle. Right? Okay. Everyone got that? Good. Alright. As the first axle revolves, here's the first axle. It revolves around. That's going to turn gear 1. As the first axle revolves, it drives the second axle, which is over here. So this one goes this way, this one goes the other way as the gears interlock and go through. Okay. Now, which in turn drives the third axle, right? Because gear 1 goes to gear 2. Gear 2 is the same as gear 3 on the same axle, and gear 3 drives gear 4. Alright, so let y, u, and x represent the numbers of revolutions per minute of the first, second, and third axles. Find dy du, du dx, and dy dx as and show that blah 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 blah. You know what? It's kind of crazy that it said as Mr. Bartman will write, because how did it know that I was going to write it? That's so crazy. Alright, so what we also have to show is that dy over du times du over dx equals dy over dx. I know you really can't see that, and that's okay. I can show it to you in just 1 second. It goes right here. See it? There it is. Okay. So we're going to go back and look at these gears real quick. Okay. Because axle 1 is y revolutions per minute, axle 2 is u revolutions per minute, and axle 3 is x units per minute. So you can see how the radius is 1, this radius is 3, this radius is 1, and this radius is 2. So there's got to be something with those that we're going to use. Alright, so let's go ahead and do that right now. Alright, so here is what we know. We know that over here, according to this picture, gear 1 has a radius of 1, and gear 2 has a radius of 3, which means this one has the circumference of axle or gear 2 is going to be 3 times the circumference of gear 1 just because of it's a linear relationship. So the radius is 3 times, the circumference is also going to be 3 times the size. Alright, so that means gear 1 needs to go 3 times around for the axle, or gear 2 to go around 1 time, which makes the axle 2 go around 1 time. Alright, so what we can say is that and we'll get this out of the way here for just a second. I can't move that out of the way. Okay, I just got to minimize it. Alright, so what we're going to say here is that dy over du is going to equal 3. Okay, because that means when you look at this gear over here, this one has to go 3 times around for one of these. Alright, so gear 1 has to go 3 times around in order for gear 2 to go around once, and gear 2 and axle 2 to go around once. Okay, so then we're also going to say that du over dx, alright, that is how many revolutions for the final gear, so gear 4. So gear 4 and gear 3, it doesn't matter what gear 2 did, because gear 2 is only going to move the axle, and gear 3 is going to move gear 4, which moves axle 3. Alright, so we know that gear 4 is twice the radius, so it's going to be twice the circumference. That means gear 3 and axle 2 has to move around twice before gear 4 will move around once. Alright, so that means it's going to be 2. So du over dx is going to be 2. And I know you can't see it again, but there we go. Okay, so we have dy over du equals 3, du over dx equals 2. So that means if we do dy over du and du over dx, it's going to be 3 times 2, which is going to be 6. So that means so this one is 2, so that means gear 3 has to go around twice for every one of these. So now we're going to move axle 3 around 1 revolution. We're going to move this around twice. And we're going to move this one around once. We have to move this around 3 times. So we have to go 1, 2, 3 for axle 2 to go once. 1, 2, 3 for gear 1 to go make this axle 2 go around twice. Once this one goes around twice, it makes this one go around once. So we have to go 2 times here, 3 times here. So 2 times 3 will get us 6 times total. So we need 6 revolutions. And let's just get this out of the way. I know this thing's actually kind of annoying. We have 6 revolutions on axle 1 for 1 revolution on axle 3. Okay, so there we go. That's kind of what's going on here, and then we can just show all this stuff works out, and in fact it does. So they're not always going to be like that, but I thought I'd give some sort of like real world description on how this all works, and that's how cars work, and that way you can say, well, first gear, second gear, third gear in my car. Well, what does that really mean? Well, that just is changing the size of these gears, so that way the number of rotations that I get is either smaller or larger, and that'll kind of create more fuel efficiency or better torque or whatever you want. So how your car is geared kind of helps you figure out exactly what you want. So if you want a lot of starting power right away, so like first gear, you want to be able to get the car moving. You want this to be, if this goes a lot, you want it to be really easy to overcome that inertia and all these physics terms and stuff like that. So there is some real math, physics stuff involved with all of this. Okay, good. So now we have kind of an idea of this, maybe, we can go through and let's actually look at some of the actual examples. Alright, so let's see if I can maybe make this a little bit better. So it says, in other words, for the chain rule, in other words, the rate of change, and if you remember what rate of change is, we're really talking about, it is the derivative of our function at that specific spot. So the rate of change of y, the instantaneous rate of change at y at some specific point with respect to x, is the product of the rate of change, the derivative of y with respect to u, and the derivative rate of change of u with respect to x. So that means we can kind of do this little piece and this little piece, multiply them together, and we should be able to get the rate of change for y, the rate of change, that instantaneous rate of change, which is really what we're looking for the derivative. Okay, so finally, here is the chain rule. The chain rule says if y equals f of u is a differentiable function of u, and u equals g of x is a differentiable function of x, then y equals f of g of x is a differentiable function of x, and we can write it just like this. dy over dx equals dy over du times du over dx. Or we could say d dx over f of g of x equals f prime g of x times g prime of x. Or we can just say y prime equals f prime of u times u prime. Alright, and there you go. That is the chain rule. That's the major thing we're going to do. And that is going to be this video. That way we can shut it down here, and we'll just do some examples in the next one.